Hey everyone, we are going to go ahead and take a look at some graphic applications in Python. And what I'm going to do, if I can get to the right space, is I'm going to actually have everybody, you may have done the assignment for Module 2, you may have done that in Spider, and that was fine. Doing it in Spider was fine. I'm finding, however, that Jupyter notebooks might be better for our work. In the sense that you can isolate bits of code. You can put bits of code into sections, run those bits of code. And also, there are a couple things that I have discovered that work better at Jupyter Notebooks that don't work actually in Spider. So I'm going to convert us over to Jupyter Notebooks and have us do our work in Jupyter Notebooks from now on. If you pull up Anaconda Navigator, you'll see all of the different applications that we had. And in the past, you may have started up Spider. Spider starts outside of the browser, the web browser that you're using, whereas Jupyter Notebooks actually runs in the web browser that you're using. So we'll go ahead and start up Jupyter Notebook, and when you do that, you're going to get a screen that looks something like this. It's going to come up and it's going to look like this. It's going to be confusing at first because you're not going to know exactly what it's doing. It's giving you a whole bunch of files. Some of them are files that are completely irrelevant and you don't care about them. But when you want to start up a new file, actually, you come over here to New, and you click on New, and you pull down to Python 3. And Python 3 will start up a new Python application for you. A couple things about it when you do that is you've got a little place where you can put as many lines of code as you want. So you can put code, and then when you're ready to test it out, you can hit run. And what it will do is it will run what you have, give you any errors that it generates, or run perfectly because it's perfect code, and then give you another section. So if we do x equals bracket 1, 2, 3, bracket, and y equals bracket 2, 4, oops, that was supposed to be a bracket, 2, 4, 6, bracket, and we're ready to run that. Go ahead and hit run. It runs it, everything's fine, no error message, and it moves you on to the next. Then if you decide that you want to actually continue to build onto code, you can copy code into the next section and just keep writing more code so you can test it out. Or you can go back up to this section and write more and then test it out. So what I have done is I've created two scripts, and I've done both of them in Jupyter Notebooks. And it's important to be clear about which ones were done in Jupyter Notebooks as opposed to which ones were done in a different editor, because Jupyter Notebooks puts a very specific 5-letter kind of subtitle on the name of the file. So we're going to go ahead and load up a couple of files. Now, if I wanted to load up a couple of files, this is a fairly common sort of navigational set of tools. And I can go File, and this is where you can take one of the files that I'm going to give you. One of them is called Graphics, and the other one is called Boston Housing. You can click on Open, and you can bring that file in. And so if I do that, click on Open, and I can find the file. And here's the first one, Graphics. And I'll bring in the second one, File, Open. And the second one's called Housing. Boston Housing, I should say. So you'll see that I have two scripts here, okay? And you'll see them up here. I've got them opened actually multiple times. I didn't need to open them that many times. But you can go to whichever one you want to work on. And we'll start with Graphics, and then we'll go into Boston Housing. And what I have done is, in this Graphics one, I did it in multiple pieces. So I did a little bit at a time, tested it out, then did a little bit more work, tested it out, and then just kept copying bits and pieces of it, making changes to it. And this is just really to demonstrate some of the early kind of simple graphic pieces that we can do using Matplotlib. The first things first, let's get up to the very first box here. We've got import, and the library that we want is Matplotlib, but we don't want the whole thing. We want a very specific piece of it. The specific piece that we want is pyplot. So matplotlib.pyplot, we're going to import that, and we're going to call that PLT. So we'll go ahead and do that. And then on the next line, we're going to import pandas as PD. I'm not 100% sure we use pandas in this one, but I imported it anyway. And then we'll use NumPy. I know we use NumPy in this one. NumPy is a number processing package, a number processing library that we use, and we call that MP. You'll notice that each time you load these, you load them with a standard alias. Matplotlib.pyplot is always PLT. Pandas is always PD. And NumPy is always MP. And other packages, commonly loaded packages, have similar aliases. Okay, first thing we're going to do is we're going to set up a couple of variables. And the variables we're going to set up are going to be x equals 1, 2, 3, y equals 246. And those are just lists of variables, right? There's only three numbers in each of the lists. And that's to allow us to demonstrate the first of our plots. And the first of our plots is going to be a simple line plot. When you say Plt, which of course represents the matplotlib pyplot, and then you specify the specific kind of plot that you want, which is the next thing that you do, you're saying a line plot if you say just plot. And that is followed by your coordinates, x and y, which we set up here. So when we decide we want to do a Plt plot of x and y, it'll give us basically this line. Okay. What we'll first do is it will give us this line in an empty square box. And we'll have nothing here except for the tick marks and no axes and no title. Okay. So we decided we want a title. And the title is going to be, so we decided that we were going to set this, set a title actually. And so we want the title to be our first plot. And that's going to be the graphics. Now most of the time when you see graphics in something like the plot title, you'll have it in single quotes. And that's what we have here. We have it in single quotes. But we have some single quote stuff here that is not necessarily a string. We'll get through that as we get through the rest of this command. So we're using the Plt as part of the matplotlib. And this time we're specifying a title. So that's the command that it uses. The title name is our first plot. That is followed by a font dictionary. And the font dictionary, what it allows us to do is specify the font name, and the font name is basically the type of font that we would use for the title, and then it also allows us to specify the font size. And in this particular case, the font size is going to be 20, because we want to be able to see the font size, and the font name is going to be Comic Sans MS, which is just a style of font. We could use Courier, we could use whatever font that's in the font dictionary. So when we specify that, it's going to generate for us this title up here, our first plot. And then the next thing we're going to do is we're going to specify our labels. And these are going to be our axes labels. Again, we're going to use the Plt library, but in this particular case, we're going to use two different commands. One of them is going to be the X label, and the other one is going to be the Y label. And that's all part of the Plt library as part of matplotlib. And we didn't do anything really imaginative here. It's single quotes x-axis and single quotes y-axis. And then the last thing is this Plt show. And Plt show, basically, when you build a plot, you put the plot in sort of like a plot buffer. And the plot buffer will hold it in most cases and not show it to you until you do this Plt show. Plt show sort of dumps your plot buffer. And whatever you have in the plot buffer, it will go ahead and dump it and clear the plot buffer so that you can create the next plot without the two plots running into each other, and you can demonstrate or show both of them. In this particular case, we only have one. So when we do the Plt show, it takes everything that we've specified here and it plots it out to the screen and clears the plot buffer so that the next time we want to run this, it's starting from scratch. So let's go ahead and run this, and it gives us what we want, exactly what we want. We run the code, it gives us the actions up. Oh no, we ran into a problem. What did we run into a problem with? Oh, I forgot to run the first part. Oops, that's what happens when you don't run the first part. Let's run that. Okay, when you run these libraries and install these libraries into your environment, they impact the environment until you end your session. So I don't have to run those again. I don't have to run those each time. In this particular case, I can now run these. That looks fine. It gave me my title, it gave me my axes, and it was able to use Plt because once I'd imported it, I defined it. All right. What I did from here on out is I basically copied the code and moved it into a new section. And I did that to demonstrate the changes that I was making. So you can see the old code and you can see the new code. You don't have to do that. What you can do is you can come in here and you can test this out and you can make sure that it works. And then you can start doing fancy stuff with it. Like you can add different, colors and different shapes and stuff like that. You can just do it directly on the code here and you can run this as many times as you want. Again, the way I did this was to sort of copy and make it more complex and more difficult each time, so you got a better idea of what it was doing. So in the second iteration of this, I've added numbers to the lists. So I put a 0 on both the X and Y list, and then I just added the next one in the sequence. In the X list, we're going up by 1, so it was 4, and the Y list, we're going up by 2, so it was 8. I'm going to build a plot again using X and Y, but this time, instead of having just 3 numbers, I have 5. I'm going to add a title. It's the same title. I made no changes here. I'm going to add X and Y-axis labels. I made no changes here. But this time I'm going to change my tick marks. I want there to only be integers here. So we start at 2. Now, this is important because the X or the Y-axis accommodates the Y list. So since it knows that there's 0, but 0, 0, so I don't really care. And then 2 through 6 on the first plot, it accommodated the axes, okay? And it did the same thing on the x-axis. It has half the numbers, so it accommodated the values that were actually in the variable x. So that's kind of a good thing. It will do that for us, and I'll show you kind of in more detail how that can help or hurt you. Like I said, we've expanded our lists, but now we're going to lock in our tick marks on the axes, because we don't want the 0.5, 0.25, all that. We just want the integers. So we're going to specify, again, using the Plt library, we're going to specify the x ticks and the y ticks, and those are specified as lists here. Lists are always put into brackets, and they're in parentheses because it's part of the Plt x ticks, Plt y ticks functions. And then we'll go ahead and do Plt show. We run this code, we get this plot, and you'll notice that the x-axis is set to the right tick marks, and the y-axis is set to the right tick marks as well. Okay? Nothing else really has changed. We're going to come down here, and we're going to start setting some different tick marks. And the only thing I'm changing between this first iteration and this next iteration is to add a number into the y-axis. And I'm doing that to demonstrate to you how the data or the plot will accommodate the tick marks and the data. In this particular case, we said we wanted the tick marks to be 0, 2, 4, 6, 8, and 100, and it did that. It crammed everything down here at the bottom, and our plot is located down here at the bottom, but it still accommodated our request to have a 100 tick mark. And the next one, we said we wanted to have tick marks of 0, 2, 4, 6, 7.5, 8, and 10, and it did that, and it put the 7.5 in there. So you have a lot of power in, either how you set your tick marks or the data that you include to show or shape how your plot actually comes out. The next thing we're going to do is we're going to add a legend. What does this mean? What are we actually doing in this plot? We can look at it, we can kind of figure it out, we can kind of look at x, and then we say, okay, wherever the line is, x is 1/2 of y, or y is twice x. So if we were to say that this plot is actually a 2x, it's a 2x plot, we can put that in as our legend. So to do that, we don't really make any changes to some of what we've looked at, but we do add something. We add something in two places. The first thing we add is in the actual plot command itself. In the past, it was just Plt plot xy, but now we're saying, okay, we want a label here, and that label is going to be, and because it's a string, it's going to be in single quotes, it's going to be 2x. Everything else is the same until we get down to the bottom, and before we actually plot it, we say Plt legend, go ahead and include my legend. I've set my legend up here by setting label, but now I want it to actually, there's a label to the plot, there's a name to the plot. This label command actually just names this plot. Legend says, okay, if there's a name to this plot, show me that name, and it in fact does that, and that's what we get. So we set the name first as the label, and then we plot as the legend, and we get that there. Okay. Now we're going to make it fancy. So right now it's just a boring old blue line, and now we're going to add some specifications in here to kind of make it clean and kind of cool looking. All right. So, and what we do is most of the specifications are going to be set on the plot command itself. The x and y are the same. We're still going to use the 2x label. That's all the same. But now we've added all this other stuff. Okay. So what have we added? We were going to make the line red. So we've added color equals red. Red is a string in single quotes. Okay. We want to make our line a little wider. So instead of it being set to 1, we'll set it to 2. We could set it to 2. We could set it to 10. We could set it to 20. It's just what the what the visual preference is. Instead of it being a solid line, let's make a dashed line. So line style is going to be set equal to dashes in quotes. And then where the two pairs of numbers meet, we're going to put a marker there. So we'll have dashed lines, and then where like 1 and 2 meet, we'll put a marker. And where 2 and 4 meet, we'll put a marker. Okay, and the marker is going to be basically a dot. So we just put a period in there in between two single quotes. But that would be pretty useless if it was that actual size. So we're going to change the size of the marker. We're going to say marker size is equal to 20. And the other thing we're going to do is the marker is probably going to be red because we said we wanted the color to be red, but we want it to stand out a little bit more. So we're going to go ahead and say market color, or market edge color, I should say, equal to blue. Now blue can be in double quotes or single quotes, it doesn't much matter. I think they're kind of interchangeable in a lot of cases in Python. We'll go ahead and change that here. And when we run this, it will change our line. Now everything else is the same. The whole shoot match should be the same. So we'll go ahead and, because we're clicked into this particular box, when we run it, it gives us our plot. And it looks good. And we have all these settings here. We have the line width is wider, the line style is set, the marker is set to a dot, but we wanted it size 20, and we also wanted the edge color to be blue. Okay. All right, so that's good, that's done. But now we're going to add a little bit more to this, and we're going to plot. First of all, we're going to make it a little bigger. So we've got something called Plt Figure. Plt Figure, also part of the Matplotlib package or library. The figure piece is, okay, we're going to start messing with the overall shape of the figure. Okay, and specifically what we're going to do is we're going to set a size. The size is going to be 5 inches by 3 inches. And we also can set the kind of the dots per inch or the clarity of the graph. In this particular case, we're going to set it to 150, so 150 dots per inch. We could set it to 300 dots per inch. It's just what our preference is. One of the things that is kind of cool in this package is we had to put a whole lot of work into typing all this stuff in to specify kind of the things that we wanted. And so, but there's a really kind of quick and dirty abbreviated way of doing that. And we can come down here, and instead of typing all this stuff, which I've now commented out, we can do the PLT plot. The XY is the same. Okay, and before we put in our label, we can just put in single quotes 3 parameters. The 3 parameters we can put in are color, which R stands for red, the marker, which I've used the caret or the triangle, and the line style. And the line style is just dash dash. Remember, that's how we set it last time when we set it dash dash. That's what we put up here, right? The dash dash right there. We just put all 3 of those together in a single pair or a pair of single quotes, and that specifies those 3 things without us having to type all this stuff. Okay, the label stays the same. And so PLT plot, we can run all this, basically is a very good abbreviation for much of what we want there. We can't do marker size, and we can't do marker color, marker edge color, I should say, but we may not want to. Okay. What we're also going to do is we're going to line number 2. We're going to create line number 2. We're going to plot line number 2. And line number 2 is going to be set equal to the value of x2. Okay. So we're going to first set value of x2, and that's going to be a range. Now this is where NumPy comes in, because NumPy allows us to specify a range. A range always has a starting point, and it has an ending point, and it has a value of incrementation, how much you're going to increment as you go from point to point. And that's what we have here. We start at 0, we're going to go to 4.5, and we're going to increment by 0.5. So we'll see 0, 0.5, 1, 1.5, 2, 2.5, etc. We don't actually get to 4.5 because remember, when we specify a range in Python, the last thing we specify is the first thing that isn't shown. Okay, so x2 is going to be set equal to this list, and we're going to set it up with a range, and it's going to run basically 0 to 4.0. Okay, then we're going to go ahead and set the plot. Now the plot's going to be a little funky here because we started out with x2, which is going to be 0, 0.5, 1, 1.5, 2, etc. And the second value that we're plotting, in this particular case, is going to be that value squared. So we're going to have 0.5 squared, 1 squared, 1.5 squared, and we'll plot it that way. What we've also specified is a couple of simple parameters in single quotes. The color is blue. That's what the B stands for. And we've got a label here. And instead of the label being 2x, now the label is basically our x to the second, x squared. So that'll be our second line. Okay. So our title hasn't changed. We can our labels haven't changed. Our tick marks haven't changed, except for we commented them out because I don't want to force these ticks to actually be what I want them to be. I want them to accommodate the data, and the data is going to exceed 10. So I commented this part out. So once we have a label, we can add it to the plot. We're going to have a label. The label is going to be, we've got 2 labels actually. The first one is we've got a label for the first line, which is 2x. We've got a label for the second line, which is x squared. And that's 2 labels, so when we plot the legend, we'll include both labels. The last thing we can do is we can say we want to change or save this, and this we're going to save this to mygraph.png, and we're going to say dots per inch is 300. This is basically saving the graphic out to an external file outside of my Python script with a dots per inch size of whatever preference I want. When I run this, I get exactly this. We get our first plot, just our title like we've always had, x-axis, y-axis, just like we've always had. We have not specified our y-axis ticks, so those actually were set up to meet the data, and the data go all the way up to 16. Because when we get to 4 and we're doing 4 squared, we're getting to 16. So you see that the data is kind of deriving with the tick marks. But the tick marks are still being set for the x-axis because those values don't change. Or we actually don't exceed those values. So the first line that we have is 2x, and we see 2x. That looks pretty much like what we've seen in the past. And it goes exactly where we want it to go, all the way up to 8, 4 and 8. But when we start squaring that value, that value starts becoming much larger, much faster. And so while it kind of dwaddles down here lower than our 2x, it rapidly gets to a point where it exceeds and goes on up and would go up literally exponentially. We have created the plot. It's bigger. It has both of the lines. It has both of the lines accounted for in the legend, and it's now saved off to an external file called mygraph.png. Okay. All right, that's the first plot. That's the simple plot. And what I want to do now is I want to take a look at a more complex plot, and this is one called Boston Housing. I called it Boston Housing for a reason, because Boston Housing is the file that we're going to use. Okay. Let's run through the script real quick and see what it does. And I think you will find that this is similar to what we did in R, and also similar to what we did in the previous script. So the first thing we do is we set all of our libraries. So we import pandas as PD, we import matplotlib.pyplot as PLT, we import numpy as MP. We have a new library we're going to use because we're going to create a heat map. And so that library is called Seaborn. So we import Seaborn as SNS. And then I'm also importing OS so I can use that to set my current working directory, so I don't have to fool around without trying to figure out where the file is. So I'll go ahead and import that. I'm going to set my current working directory. Now, when you load this script, pay attention to this step because this will mess you up. You will have to find out what your local directory is. Now, remember, to find out what your local directory is, at the command line, you type in os.getcwd, get current working directory, open paren, close paren, nothing else, and hit return. It will tell you what your current working directory is. The easiest thing for you to do to make sure you can access your file is to put your file in that current working directory. Okay? What I have chosen to do is I've chosen to do the not as easy thing, and that is I'm going to set my current working directory to be where my file is. So if I've downloaded my file to documents or I've downloaded my file to downloads, I can go ahead and set my current working directory. I'm using the OS library. I'm using the CH, which is change directory, part of my OS library. And I'm specifying the actual path name of that particular file. If it's in downloads, you'd set it to downloads. If it's in documents, you'd set it to downloads or documents. But the reason why this particular command will not work for you is because it's got my name in it. You'll see that it's C:\\users, /my name, and then // documents. So if you're savvy enough that you can set that pathway on your own, go ahead and set the os.chgir. If you're not, move your data file, your Boston Housing data file, which I will give you again, move that into your current working directory. Use your os.getcwd open paren, close paren to find out what that is. Okay. Once you've got all that set up, and if you move the file into the current working directory, I'm going to tell you to comment this out. Take that out because you don't want to mess up your current working directory. But in my particular case, I'm going to keep it. Okay. Then it's going to set a couple parameters for me. Now, remember we did this last week. We set some options. We didn't want to have Python abbreviate for us. Pandas actually abbreviate for us. And Pandas makes some decisions. If it feels like the file's too long, it'll show us the first part of the file, it'll show us the last part of the file, and it won't show us anything in the middle. And that's because we have to set it to tell us, we set it up so it shows us all of them, shows us everything. We set those parameters. And we do the same thing with the columns. So by saying PD, which is Pandas, we're setting options in Pandas. And the option that we're setting is display max rows. And we're going to say we want it to be 999. Well, the data file we're using is Boston Housing has 506 records. So that's good for us. Okay. Same thing we'll do with columns. PD options, display max columns, we'll set that to 20, and we know that the Boston Housing set, I think, has 14 columns in it, so we're good there. Okay. All right. Now the next thing we're going to do is we're going to read in our data file and save it to a data frame called df. And df was kind of convenient, just simply because it's a very convenient name to use. I would encourage you, though, to use data frame names that are more meaningful. In fact, there's no reason we couldn't have used housing for this. I just chose df just because it's easy. It's easy to type. Okay. So in this particular case, df is going to be equal to, this is the pandas package. I'm using the read CSV part of the pandas package, and I'm reading in the Boston housing CSV file from whatever my current working directory is. Okay. So that will bring in my file. Then I'm going to look at the header. I'm going to print, and that's going to be my data frame. And in the case of Python, the commands are basically the same thing. They're just different formatted. In this particular case, if I want to look at the top three things, so the top three rows of my data frame, it's data frame, period, head, and then 3 in parens. And if I want to look at the bottom three things, it's data frame dot tail with a 3 in parentheses. It's the same kind of concept as what you looked at in R. The next thing we're going to do is we're going to get ready to run some scatter plots. Okay? And to run scatter plots, the easiest way to do this is just a set of variables. Now, these variables aren't very descriptive either. We could have used median value, room, and age instead of x, y, and z. But x, y, and z work. So we'll go ahead and set x equal to, and in the case where we used to actually access a particular column using the data frame, $, and the variable name, or the column name, we're doing something very similar here. In Python, we're using the data frame, and instead of using the $, we're accessing the name of the column in single quotes and square brackets. That will take all 506 values for median value and drop them into x. Okay? Same thing with this next one, with y. We're taking the data frame, and then that's followed by in square brackets, the, and single quotes, the actual name of the room variable. And we did the same thing with z. On z, we put in age. So now x is populated with all the median housing values, y is populated with all of the average rooms, and z is populated with all the average ages for the 506 neighborhoods in the Boston housing set. Okay? Then I can run some scatter plots. The first thing I'm going to take a look at is I'm going to take a look at how median value looks against room. And you would think that median value and room would probably look pretty good together. That would probably have a pretty high correlation. I use the plt.show to show me that graph. Remember, there's like a internal buffer that when you create graphics, it saves it in that internal buffer. When you use the plt.show, it empties that internal buffer. If you don't do this, what will happen is when you run the first scatter plot, you'll see the first scatter plot. When you run the second scatter plot, it dumps it into the same scatter plot. The problem comes in that you're using the same scale for both scatter plots, and so it really messes up your view. So if you want separate scatter plots, you have to put the plt.show to sort of empty out that buffer before you generate the next one, and you'll get the two separate scatter plots with the right scales on the x and y axes. Okay. That will give us those scatter plots. Okay, what about the correlations? What I think I'm going to do at this point is I'm going to go ahead and run this script so I can show you the results before we get into the correlations and the heat map. Let me go ahead and run the whole thing. And just ignore the rest of it. We got our first 3 rows, loaded our file, fine. We got our first 3 rows. We got our last 3 rows, okay? We got our first scatter plot. And the first scatter plot looks like there might be a positive correlation here. You've got a kind of a diagonal line goes from the lower left to the upper right. So and remember what we're looking at in that particular case is we were looking at x, y, or in this case, median value in the number of rooms. So the median value in the number of rooms probably pretty highly correlated. In this particular case, we're looking at the age of the house and the median value, and it looks like there might be a bit of a downward trend in the sense that the higher the age, the lower the median value of the house. Okay, so I decided to run correlations, and I did that using a command called, where are we at in the script? Here we are. And this is out of the NumPy package, so we're using numpy.corrcoef. It's, they're called different things in every single package. In this particular package, it's called corrcoef. And we're just basically looking at x and y. And x and y was median value in room. So what is the correlation between x and y? And once you calculate that out, print it out on the screen for me so I can actually see it. And then go do the exact same thing for the median value and the age of the house. And that's what it's done here. And it showed me that there's an almost 0.7 correlation between median value and the number of rooms. It's also showed me that there's a negative 0.376 or 0.38 correlation between the number of, or sort of the age of the house and the median value. So that makes perfect sense, and that's backed up by the correlations. Okay. Now the next thing I want to do is I want to set up for a heat map, and so I'm going to do this. There's actually a couple things that we have to do. One of the commands looks pretty hairy. I'll try to go through it as best I can with you. But the first thing we're going to do is we're going to set up a new variable, and that new variable is going to be CORR, and that's actually going to be something that's even simpler in Python than it is in R. We'll take the data frame, and the data frame with a .corr function on it. And what that does is it sets up our 2x2 matrix that has all the correlations in it. And it's as easy as that. It's the simplest way to do that. So CORR represents our data frame that has the 2x2 correlation, the matrix of correlations. The next thing I'm going to do is I'm going to say I don't want to see this as a tiny plot. I want to see this as a big plot. So I'm going to use the Plt Figure, the figure part of matplotlib/pyplot, and I'm going to specify the figure size, and I want the figure size to be 15 by 15. I want it to be squared because it's a heat map. It's a 2x2 matrix, so it makes sense to have it as square. You can play with these numbers however you want to show whatever you want. Here comes the heat map. And the heat map is a little scary looking. So this is where we're bringing in the Seaborn package, and the Seaborn package is specified by SNS. It is followed by heat map, which is the command out of the Seaborn package that we're actually using. Okay, we're using CORR as our data set. Okay, the variable minimum is -1. The variable maximum is 1. And those are the two maximums on a correlation, so that makes sense. Okay, and that's going to govern the shading or the color that our heat map is going to show. The closer it is to -1, it will be one color. The closer it is to 1, it will be a different color. The center is 0, so the 0 will have no color. The SMS diverging palette, this is basically this CMap is governing which colors we're using. And these can be played around with or altered as we see fit. Annotation equals true says we do want each square to have its own value written in that square. Otherwise, we wouldn't see the actual correlations. And do we want a square, actual square line written around each square? We set that to true. Okay. Then we actually set up the labels, basically the labels, and what are the tick marks, and what are the labels that we're going to use, and where are we going to put those? We're going to put it over to the right. So these are all little kind of parameters. The actual heat map command is at the first part, and the second parameter governs where the labels are going to go and what they look like. Okay. So, and then when we're done with that, we're going to save it. We're going to save it to mygraph.png, and we're going to give it a dots per inch of 300. Well, when I ran the script to show you the first parts of it, it actually ran the whole script. So here's my heat map, and my heat map shows me exactly what I would expect to see. We did specify in the second command that we wanted the horizontal alignment to be right, and we specified what the range was. So that's what put this over here on the right side. This is the command that set all that up. And then the labels are set up so that's properly annotated with the correlations for each of the different pairs. So that's all done. The only thing left to check is to make sure that it wrote it out to mygraph.png, which is what I asked it to do. And it, in fact, did do that. It's a little small, but you can always go into the video editor, and you can increase it in size, and modify it, edit it, do whatever you want, and save it, and keep it, all that good stuff. Okay. Going back then to Boston Housing, you can see how this whole script, you put it all in, you hit run once, it generates everything you need, everything looks great. But now if you want to go back and you want to make slight changes, you can make changes. Maybe you want to use different variables here. Maybe you want to build different scatter plots. Whatever. You go ahead and just make those changes here, and then run it, and you can see what the results are when it runs. Or you can take a copy of this script. You don't want to mess up what you've done that you've got working, and you just copy it into the next space and go ahead and make your modifications there and then run it from there. Okay, I think that's a good start for us to take a look at graphics. Let me know if you have any questions. Here's your assignment, and I'll be as sort of open to this as I can. I'd like you to go through, and I'd like you to create a file in Jupyter Notebooks. One of them's for graphics, and the other one is for Boston Housing. And I'd like you to make it different from mine. Use different colors, use different shapes, use different line styles, marker styles in the first script. Maybe use different variables. If you turn in something that looks exactly like my script, I'll live with it, but I won't be happy with it, because I want you to explore with this, and I want you to basically step out of my shell of what I've shown you, and and learn by doing. So I'd like to see something that looks a little different. I'd love it to see, for example, a heat map that has different colors. I'd love to see, different formatted, whatever it is you want to do. I'll give you both scripts, and I'm sure you'll be able to load them up. But I'd like to see you make some changes to it. And that'll be your assignment for this week for the Python piece. Okay, if you have any questions, let me know.